Hi guys, last class we learned about dispersion. Let's recall dispersion. So dispersion is a phenomena, a property of light. So when light travels to a prism, so what happens? This white light, it's split into seven colors. So this phenomena only known as dispersion. The splitting of white light into seven consistent colors is known as dispersion. So what is the reason for dispersion? So we know that the light is having several colors, each color having each wavelength. So that's the concept of wavelength. Light contains several wavelengths, so many. And when each color it contributes each wavelength, so that wavelength is responsible for the dispersion. So when it passes through the prism, so each wavelength will be deviated with certain angle. Now what are the colors we can get from the prism? So when white light passes through prism, so here an optical phenomena, so that is known as refraction. Refraction happens at one side at here when light is passing from rarer to denser inside. Now here the white light is dividing into seven colors. So this is only we known as visible spectrum. Visible spectrum. Visible means which we can see, that is visible. And spectrum means nothing but a band of colors, a several colors we call as spectrum. So in this visible spectrum we can see the main colors are from the down to top. It's a violet, indigo, blue, green, yellow, orange, red. So to remember that, so from the prism the red colors deviate least. So the red color it deviate least, it will bend very less. Why? Because the red is having more wavelength of red is high. Wavelength is high. So the dispersion is due to because of the wavelength which are the present in the white light, and red is the deviates least because it is having greater wavelength among all other colors. Now whatever the colors we can get from the out of the prism, so that is known as visible spectrum. Now when we combine two prisms, invert prisms, now one prism will disperse light and another prism will combine light. So this experiment is did by Newton by asking a question, where these colors are coming from. These colors are present in the prism or these colors are present in the white light. So he got an answer from this by keeping two inverted prisms. Now one prism is disperses light and another prism combines light. So finally he got an answer that the colors are not present in prism, it is present in the white light. Now this is one of the optical phenomena, and we might observe same phenomena, same type of colors in the rainbow. So how this rainbow forms? How these colors forms? So that we will learn in the concept of formation of rainbows. Now first, rainbow is caused due to because of the rain droplets. Here there is no prism. Then who will work as prism? The rain droplets. So these are works as like prism. The droplets which are present in the atmosphere. Now whenever the rainbow forms, very important case is that the rainbow always forms after the rain. What happens when once the rain is over, certain small tiny water droplets, they are trapped in the atmosphere. So they will present in the atmosphere, very small, not the big what we are seeing at here. Very small water droplets, they are trapped in the atmosphere. So when sunlight falls on it oppositely, so we always see rainbow when sun is behind us. That is a very necessary condition. Here the two necessary conditions I can give. One is the sun is always behind the observer. Then only we can able to see the rainbow. And second is the water droplet size is very small. That's why we cannot see rainbow every time. Very occasionally, because these conditions should satisfy. Now the sun should behind, that is the first case. The sun should behind observer. And the second case is that the water droplet size. Water drop size are the very small. So if these two conditions are satisfied, then let us understand how the rainbow forms. Now if I can play back this slide once again to see. Now here you can see, so this is the water droplet which I am having. Now on this water droplet, the sunlight is falling at one particular spot. Now after that, here you can observe the splitting of colors. So here this is we known as dispersion. So here it is dispersion. Now after dispersion, here you can see the colors are not coming this side. It is not coming out of the rainbow. So what happens? Same colors are reflecting inside the water droplet. So the dispersion colors are not coming out of the water droplet. They are reflecting. So here one more phenomena. So here the reflection. So this particularly says that total internal reflection, because the light rays, colors rays are reflecting inside the droplet. If they are coming out of the droplet, there is no chance to see the rainbow. Now here it is second optical phenomena. Here is second optical phenomena, and at here the colors are coming out of the water droplet. Now here again we can observe one more optical phenomena, that is known as refraction. Now altogether here three different optical phenomena we can observe. The first one here it is refraction. Refraction means when light travels one medium to another medium, what happens? It will bend towards to the normals when it is travel in the air medium. Suppose it is in the glass, in different mediums. Or otherwise you can take it as a water medium. So if you can take that as water, so the refraction takes place. The same phenomena refraction takes place at here. And you might got doubt. That doubt might be why the sunbeam is drawn like that, why there are the no light rays or in this direction. So in this direction also the sun rays will be fall. So on the water droplet, on every spot the sun rays will fall, but they do not cause the dispersion and internal reflection phenomena. So these all droplets are not at all cause for dispersion. So that's why these are negligible. But when we can get a perfect droplet which is at here. Now if the sunlight is striking at this that particular angle is very important. So if the sunlight is not striking the water droplet in that particular angle, so rainbow it won't form. So that is also one of the reason that rainbows do not last so much time. We can see hardly rainbow at most, depends upon the conditions, maybe 2 to 3 minutes or less than that. We cannot see rainbow whole day because the sunlight falls on that angle gets changes. Now here that angle is very crucial. So the angle of incidence of this rain droplet at this particular. So here first phenomena is refraction. Then after second the light ray gets dispersion. And third at here inside droplet again the visible spectrum gets internally reflection. So here you can see carefully the colors are not coming out of the water droplet, they are reflecting inside. That known as internal reflection. And finally on the other side the colors are coming out. So when the colors are coming out, if you can see it is a violet, that goes to red, we can get the order of that Vibzion. Now here it is red, here it is violet. Now to form a rainbow, so these many phenomena is occur. So one is first it's supposed to refract, then after it will internally reflection, then after again final goes to refraction. Now as per I said, the light rays will fall on the raindrop with all sides, but only one particular spot, the chosen point. So that chosen point is cause for at here dispersion. So in the formation of the rainbow, so three optical phenomena is there: refractions and internally reflections and again refraction, and one particular angle of incidence of the light ray, that is very crucial. Now this is the original rainbow what we observe, especially when rainy days, after rain. Now here we are seeing two rainbows. This is the lower one, very bright. So this is known as primary rainbow. So this is the first rainbow you can call, or in language you can call primary rainbow. And the second one here we can call, this is the second, so that's what you can call secondary. Sometimes you can see doubles, or sometimes it is also possible to get the 3, 4 like that, multiple rainbows also you can get it. So here I want to make you understand that the difference between the primary and the secondary rainbow. The first one is the brightness of the rainbow. You can see the primary rainbow is very bright. It's a brighter than the secondary rainbow. And if you can closely observe, so the primary rainbows are having the colors violet to red. So the red is on the top in the primary rainbow. But when you can see the secondary rainbow, the red is on the down and the violet will goes to upside. So if you can take that as an IBZR. So the red is in the primary rainbow is on the top and the violet is on the down. But in the secondary rainbow, so this will becomes opposite. The red will be on the down and as a violet will become on the top. So we know only how these rainbows are formed. So let us understand deeply how these secondary rainbows forms. So first, before that, I would like to give in details how the rainbows forms. So to form a rainbow, so you just try to remember this picture and you need to practice this diagram also. And we need to the sunlight, so that is the first point. So rainbow is produced by water droplets in the atmosphere. So after rain, certain water droplets are very small in size. They are trapped in the atmosphere. When sunlight falls on it in opposite direction, so these optical phenomena will takes place that causes the rainbow, formation of rainbow. So the next point, at a chosen angle, so if we take that as a chosen point at here, at a chosen point, the refraction occurs. The first phenomena, refraction occurs. Then light enters inside the water droplet from air. Then after what happens? It's a disperse, splitting of light into 7 colors. And after the dispersion, what happens? Again, it happens internally reflection. So here the third optical phenomena, internally reflections. And after the internal reflections, it happens fourth point, again it refracts. Now at here, the fourth point at here, the light is refracts. So if you can write that order, first one, it enters. While entering, it's supposed to refract. So this is the first one. Second point, disperse. Dispersion. The third point, internal reflection. The internal reflection happens at here. That's why the dispersion rays are reflecting inside the water droplet. It is not coming out of the water droplet. So that phenomenon known as total internal reflection. And again the fourth, again here it happens, again the refraction. And finally we can observe the rainbow at here. We can see a rainbow when the sun is behind you. Always sun should be behind the observer. This is also one of the reasons because your brain must project sun rays back to your eyes to create a virtual image of visible spectrum. So this is how a rainbow forms. Now, if we can go ahead to understand the primary rainbow and secondary rainbow. Here you can see, understand the diagram carefully. Now here I am having the two things up to this diagram. If you can take this as part at here. Now these two water droplets are shows about primary rainbow. And above water droplet shows as secondary rainbow. The main difference in the primary rainbow and secondary rainbow, if you can clearly observe the diagram here, so that is due to because of the internal reflection. So in the primary rainbow, the water droplets are the internally reflecting only once. So this is the total internal reflection. The water droplets are the reflecting only once. But in the secondary rainbow, you can see the water droplets are reflecting at here 1 and at here 2. In the single raindrop, total internal reflection takes place twice. So if those conditions are present, then we can able to see the secondary rainbow also. Usually those particular conditions should present the position of sun rays with respect to water droplet. That is a very main important point. So for the primary rainbow, the total internal reflections takes place only once, but if we are able to see secondary rainbow also, in that case you can think that total internal reflections happens twice. So that's the reason we can able to see the secondary rainbow. So those secondary rainbows also we can see very rare, not regular. Usually we able to observe primary rainbows mostly. And not only that, here one more important point is that is due to the angles. So if a rainbow is formed after one internal reflection, it is called primary rainbow. So in this case, the violet emerges at an angle 40 degree. So this angle is the violet color emerges out from the rainbow at an angle 40 degree. It means if you can able to observe the violet color with respect to human eye, here where we are observing. Now the angle between the violet color and our line of sight, here it is 40 degree. It happens in the primary rainbow. And red color, so this angles between the 42 degrees. So if you can write for primary rainbow, the violet color and red color, violet to red color, the angles are the 40 degrees to 42 degree. And rest of the colors angles present in between, means the line of sight where we can see and how the color falls on our eye. There should be certain angle. So in that angle only the rainbow is observable. If this condition is not happens, we cannot able to see the rainbow. Now for the same secondary rainbow, if you can take these angles for secondary rainbow. So in the secondary rainbow, as we discussed, two internal reflections takes place. So here the ones and here the ones in a single water droplet only. So that's why it's called secondary rainbow. So in this case, the violet color emerges 55 degree, violet color emerges 55 degree and red color emerges 52 degree, and rest of the colors are present in between. So to see the rainbow, to observe the rainbow, so many conditions should satisfy. Among that, the very first one is a tiny water droplet should present in the atmosphere, and sun should behind the observer, and at one particular spot the angle of incidence, that angle of incidence of the sunlight on the raindrop at one particular spot, that causes dispersion, and after total internal reflection, then the visible spectrum appears. When the visible spectrum appears, different colors will come from the different water droplets. It is very deep to understand. I am not giving that much explanation. So if you can clearly observe this diagram, which is on my right side, so the observer is observing only one color from a single droplet. So here he is observing as a violet color, and from the another droplet he is observing red color. So the position of the observer with respect to water droplets, that is also matters a lot. With that angle only, if the colors are incident on the human eye, then we can able to see the rainbow. So this is all how a rainbow forms.